talk about review of vectors today, and we're going to start with some quick conceptual questions for you. So I would like you to pause and think about the answer to these questions as I show it to you. Okay, so what are the two essential vector products that you will be learning in Calc 3? Right, I think everyone would agree with me that the most two essential vector products in Calc 3 we'll be learning is dot product and cross product, and I hope you already know how to compute them. Right, and in fact, we will be computing many dot product and cross products as we progress in the course. Okay, the second question is, how do you find the angle between the vectors, right? I'll give you some time to think about it. All right, so to answer that question, we need to talk about the property of dot products. So as you can see here, right? So this is the equation that we can use to calculate the angle between two vectors u and v, and this is one of the most important thing that you need to memorize from taking away from this lecture. All right, how do you know if vectors are parallel and perpendicular to each other? Well, since we have learned about that equation, why not go ahead and take advantage of it, right? So let's say if I have, let's start with the easy one, right? What is the quickest way we can figure out if two vectors are parallel to each other is if the vector components are scalar multiple of each other, right? So if you multiply one vector by a scalar, you get another vector. That means these two vectors are parallel to each other, right? That's as quickly as it gets. And if you go to this equation, and you will see that the theta between the two vectors will be 0, right? So if you make this angle 0, the vectors are parallel to each other. So what is the value of theta that will make these two vectors perpendicular, right? It's gonna be pi over 2, right? Or negative pi over 2 for that matter, but they're the same thing if you plug into cosine. Right, so that means the cosine of pi over 2 equals to 0. So that's the whole idea that is the key to tell if two vectors are parallel to each other, or if we can simplify this equation, right? So if this is 0, right, and these are just two scalars that are positive. So technically, as long as the dot product between two vectors are 0, the vectors are perpendicular to each other, right? As you saw in this equation right here. Okay, so there you go. Right. So what are the physical significance of these two equations? I'll give you a hint, right? One is something about the alignment, and the other one is something about the area. Okay, so, right, as we discussed before, right, this equation that we have right here it shows you the relationship between how our two vectors are aligned, right? So how aligned is u with respect to v, and we can figure out the angle by that. But if we switch from cosine to sine, we get a completely different equation that also carries its own physical meaning, and that physical meaning is the area of the parallelogram that these two vectors will create. So let's find a better example, right? So if we have these two vectors, right? Let's get rid of this, right? If I duplicate them and align them like that, so the equation u cross v, the magnitude, equals to the magnitude of u times the magnitude of v times sine theta. This is going to be the area of the parallelogram. Okay, area. Well, sometimes the question will ask you, well, what if I just want the area of the triangle, right? I don't care about the area of the parallelogram, right? I just want the area of the triangle. Well, that's easy enough. You just half, right? You just multiply this equation by 1/2 to get the area of the triangle. Okay? All right, so the next question will be, what is a unit vector and how do you find one? Right, think about it. Well, a unit vector by its definition, right, is any vector that has a magnitude of 1, right? So, and then if we to find one, we can just divide, right? Divide a vector by its magnitude, or quote unquote the length of the vector. What is orthogonal projection and scalar projection? Okay, this one is a little bit tricky, so I'm just gonna give this away to you. If you're interested, you can go ahead and listen, but it's not a super big of a deal. But I think it's still interesting to know. So orthogonal projection is essentially we're projecting a vector onto another vector. Well, so for example, we have a vector u right here, we have a vector v right here, that if we project u onto v, we get, so let's say if I shine like a light, right? I have a parallel light source onto it, a shining light source, and this is the projection of u onto v is literally the shadow of the u, right? Or alternatively, you can think of it as how much of v does u have in the v direction, right? So, and then scalar projection, and by the way, the way you find that is just through this definition. Okay, it's just through this definition. And then scalar projection is literally just, instead of giving you a vector out of it, right? Instead of giving you this vector, it's just going to give you the scalar version, the scalar or the magnitude of that projection. And then this is the equation that you can follow. And then actually, if you have the scalar projection times the unit vector in the same direction, you actually can return to the orthogonal projection. All right, so now I'm just going to show you all of the notes that I just presented to you, and you can find the PDF version of my notes under the video. I'm just gonna carefully scroll through them so you can take notes if you want, but I don't think you need to because they're all available, right? So this is how you compute cross product. That's interesting. And we just talked about the area. Oh, one more thing. Sometimes I will mention about the right hand rule, and I think it will be beneficial for you to know about the right hand rule. You can just Google it, and it should be very easy to find. But this is sort of the graphical illustration of that. And let's talk about question time. Actually, we don't have any questions. This is a review. But next time, in the next video, we will go through the same, we'll go through more conceptual questions, but of course related to a different lecture content. And then I will share my notes to you. And next time we will actually start learning some of the techniques that I have developed to solve these difficult problems. Okay, I'll see you guys next time.